Want to see a full app running inside Kubernetes with real pods, services, and everything working just like in production? Well, this is it. We've reached part 4, the final chapter of our hands-on series, and today we're going to show you how to deploy the entire app using Kubernetes and Kind. You'll learn how to create real deployments with replicas, get your pods up and running, and configure services to connect everything smoothly inside the cluster. If you're just joining, the first 3 parts are up, totally worth watching, but if you've been following along, get ready because Herbert Pereira is back to wrap this up with a clean, working deployment.
Welcome back to part 4, the final part of this special edition on Kubernetes Ingress with Kind. Now we'll configure the Kubernetes manifest's YAML files for the deployments. In this example, I have a deployment for the homepage service. Let's copy and paste the code and go through the explanations. Here I'm creating a Kubernetes object of type deployment, which will be associated with the home service of the application. It will run with 2 replicas, meaning each deployment will have exactly 2 replicas configured. This means that there will be 2 pods for each deployment, and within the pods, there will be the actual execution of the application containers. Additionally, we will also have labels which allow the deployment to accurately select exactly the pods that belong to this specific component. Containers will be created with the same name, home app, using the custom image we previously created and uploaded to the cluster, configured to respond directly on Nginx default 80 port. Here, we just have a few basic resource limitation settings. It's really as simple as that. This manifest creates a deployment specifically for the home. Similarly, you will also need to create the deployment for the product service, which essentially follows the same detailed step-by-step explanations as the home deployment, but is now applied directly to the product applications component. This deployment will also run with 2 replicas to respond equally and consistently on port 80. For the checkout, you will also need to create the corresponding deployment, ensuring the proper setup and execution of our pods. In the same way, this deploy will have 2 pods. We have successfully deployed the pods, but we still need to configure the service which will be responsible for managing and ensuring seamless internal communication between the components. Now let's go ahead and configure the service Kubernetes object through a manifest YAML file. For the home component, we'll set up a cluster IP service. Although cluster IP is the default option when it's not explicitly specified, we're explicitly declaring it here to guarantee stable, consistent, and reliable internal communication. And now let's configure all the service manifests. For the home, a cluster IP service will be created. This is already the default when not specified, but here it has been defined explicitly to ensure internal communication. In the same way, we're going to configure the manifest for the product microservice, which will also respond on port 80 and will be of the cluster IP type. And let's repeat the same process for the checkout service, also creating a dedicated and specific service for this application's component. With deployments and services fully configured, we now finally reach the icing on the cake, the Kubernetes Ingress special service. Let's go ahead and carefully configure our ingress. We can now safely close the service manifest files. Let's now open the e-commerce ingress manifest, which will be directly responsible for coordinating and managing all the detailed routing logic in conjunction with the powerful ingress controller. What we have here is an object of type ingress named e-commerce ingress, which also includes a specific annotation already configured. The annotation is used precisely to define route changes. This means that when the route is product, it will be directed to the corresponding service for that component. I mean, directly to the product service running on port 80. When the route is checkout, the incoming traffic will be directed straight to the checkout service. And when the route is the default e-commerce route, the traffic will be directed to the homepage service with internal communication via port 80. It's as simple as that. Once you understand the theoretical basis, implementation becomes much simpler and clearer to understand. Now that all the files are properly configured, we can go ahead and move on to the deployment and run all the kubectl commands needed. If we run the command kubectl get pods, we'll see that there are no pods configured yet. I'll check which folder we're in at the moment. I'm already in the right folder, the exact one I need in order to properly access the manifests. So let's begin by running the kubectl apply command to successfully deploy the homepage service with 2 replicas pods. Next, we'll run the same kubectl apply command to deploy the product service page and then proceed to deploy the checkout microservice, also configured with 2 replicas. Now, by running the kubectl get pods command again, we'll see 2 pods running for each component of the application, thanks to the replicas section defined in the deployment manifest files. Let's clean up the screen first. Likewise, we now need to deploy the Kubernetes services objects. Running the kubectl get service command, we can immediately see that we already have the standard cluster IP, the default internal service used for the cluster's reliable internal communication. Now we're going to deploy the homepage service, followed by the product service, and finally the checkout service in the cluster, all executed step by step using the kubectl apply commands, followed by the Kubernetes manifest file using the flag F. Now, when we run the kubectl get service command again, we'll see that the new 3 cluster IP services for the pod's internal communication have been successfully created. Now let's focus on the deployment step for the special service, the ingress. First, let's run the kubectl get ingress command, and you'll see that no ingress has been created yet. Now let's create our own. Remember, we have already deployed the ingress controller, so we have just created the ingress service. When we list again to validate, we'll see the e-commerce ingress running associated with the Nginx class type. If we want more details, we can run the kubectl describe ingress command, which provides complete and detailed information about this ingress. We can even see the routes configured inside the ingress. Depending on the route, you can already clearly see the defined backends, the specific backend services to which the ingress will correctly and efficiently forward the incoming traffic. Note, it's just a single ingress using one IP, serving an application with multiple paths and routes, and it can even be configured to serve different subdomains as well. Now it's time to access and to test our application. I'll go back and copy the EC2 instance public IP address. Obviously, port 8080 must always be properly released in the security group to reliably ensure correct external access to our application. Using the EC2 instance public IP address on port 8080, we can access the home page of our application fully up and running. Now let's also try accessing the product page service using the same EC2 instance IP address, but this time pointing directly to the corresponding route for this specific component, the products. And there it is, the product page service is running successfully. In the same way, we can also access the checkout page service without any issues. Now let's change the route to a checkout and test it. And that's it. Our application is running successfully. Obviously, from the home page, by clicking on the links, you can also access both the product section and the checkout section. And that's it. I truly hope you enjoyed this detailed session and gained a clear and practical understanding of how an ingress controller works. To reiterate once again, we created only one ingress, which uses a single IP address capable of intelligently routing traffic to different paths, or even extending to multiple subdomains. I hope you found this really helpful and valuable, and I'll see you soon in a future edition, in a future video.
Alright, thank you so much for watching this video, and then if you enjoyed this content, please consider subscribing to our channel. Give us a thumbs up if you enjoyed this content, and then also please leave us a comment telling us what you think about this video and also the things that you'd like to see in a new video here on our channel, okay? And then if you're interested in mastering move to cloud, DevOps, and AI with our help, please check the links in the description as well. Hope to see you in the next video. Take care and goodbye for now.